Hi everyone and welcome to another math revision with Jov. Today we're looking at this sequences question and it says A is an arithmetic progression. The first four terms are 13, 16, 19 and 22. G is a geometric progression and the first four terms are 2, 4, 8 and 16, and it says that the nth term of A is equal to the 8th term of G and wants us to find the value of n. This problem actually wants us to find the value of n such that the nth term of A is equal to the 8th term of G. And what that means is we can actually just call it A sub n is equal to G sub 8, because that's a nice short way of writing it. So how do we find A sub n? How do we find the nth term of A? Well, we actually see that it's an arithmetic progression, which means it increases by a constant value each time, which means that we must have some constant times n plus some other constant, I'll call it m. So kn plus m. K is pretty easy to see because it just differs by 3 each time. So we see that an is equal to 3n plus, and what's it plus? Well, the first term of A is 13, so 3 times 1 is 3, and we want to get up to 13, so we need to add 10. And there we go, that is an. And it is equal to the 8th term of G. Well, you can actually see that G of n, just the general for G, we get that it's doubling each time. So we must get 2 to the power of n. And do we have to multiply this by anything? Well, 2 to the power of 1 is 2. 2 to the power of 2 is 4, so we're there already. We don't have to multiply this by anything. And so that means that G of 8 is equal to 2 to the 8th power. And if you want to calculate that, that is 256. So that means that 3n plus 10 is equal to 256. Therefore, 3n is equal to 246. And then we just want to divide by 3. So n is equal to, well, what's 246 divided by 3? Well, 240 divided by 3 is 80. And then there's 2 more 3's left over, so 82. And that is our final answer, and I hope that helps.